Hi, a very good morning to Dr. Subramaniam and also the other panel of judge. Alright, so my name is Muhammad Amirul Zafran Miramli. I'm here today to present to you guys my final year project demo. So my final year project name is Smart Sorting and Defect Detection on a Conveyor Belt. So over here I have already prepared two demo, which this one, the demo one have two output over here, and demo 2 have 3 output, which means like in the machine learning model we have in model demo 2 we have 3 classes, and in the first one we have 2 classes. Alright, so from this the difference in between these two demo is this part where it's just the output algorithm, like the coding for the output. So here as you can see at the start, we have this prediction sensor which is connected, an IR sensor which is connected to my Raspberry Pi, and then after that we have a trigger node which sends 1, and then also will send nothing after 2 seconds. This is used just to avoid multiple input from the IR sensor earlier, because we have this running conveyor belt to stop. So the item on it, the prediction sensor is supposed to stop the conveyor belt when item is sensed. But then whenever the item is sensed for a few seconds, we are scared that the IR sensor will still detect it again and run this whole thing again. So to prevent that, we use the trigger node here. After that, we have this a few multiple function which technically injects few variable consist to control the servo motor. So the servo motor needed to give any instruction, we need to have a 3 node, which is to control forward or backward, and also the speed of the servo motor. So over here is the part where we stop the servo motor, and then we delay it for 3 seconds, which means it will not trigger this node which starts the servo motor back for 3 seconds, means the item will stop for 3 seconds. And then when the servo motor is stopped here, it's technically gonna run this USB camera which takes an image as a buffer, and also an file image here. So and then through that we run through our machine learning model, which is available in online, which we have already custom trained. After that, after the model predict our image earlier, it will go to several paths, 3 paths to be exact. So this path here is the where we define what should the output of it do, which these numbers indicate the direction of our servo motor. So because we are using a slide for this project, so it technically we just need to tell the servo motor like which direction are you going to go, and this trigger node here now is using to send like the existing message that they received earlier, and also send back 0 just to make the servo motor even stable, because like if you don't indicate the 0, the servo motor will still move at some random direction a bit. So for the above part here, we have this delay functions to make the image from this node where we save here earlier to become more visible, and then we use this to initialize which classes are detected earlier. And then this function is just a function where we indicate who we want to send in our Telegram message, and then indicate the type of the message which we are sending, an image, and then we put the caption of the image, where I have put like the name of the class and also the accuracy of the class. so that the user can know like how much the accuracy for it, and also we will send also the image of it. Alright, so down here we have like a few section. I will explain this later down here. So technically we have this function node. It's typically the same as the one above, but then just we need this part here just to inject our data that we gathered into our, which we need to initialize first before we inject anything to the InfluxDB node. So over here we have these few lines which indicate like the few requirement in InfluxDB. So we have some tags and field. So the field is the object score and the score of the class just now, and also the object of the class, which means we are sending the which class is it and also the accuracy of the class to our database. So over here is just part where technically this project could be started, because like technically everything is started on this. Like if this happens, like anything object is here, so it will run everything. So to start the servo motor itself, so we need to go through Telegram, where we can send few this command in our Telegram bot. I mean, to start is this one, which is run, and then we can give a command pause to stop the servo motor. So when stopping the servo motor, technically it means that we will not run anything, because no object will move on the conveyor belt. So it's technically like a switch. So over here, because we do need the ID of the receiver or the user, so we can use start to indicate what's your message ID in Telegram. Alright, so here I've already deployed my demo 2 at the back. So from the Telegram bot, which is I name it sorting bot. So here if I press run, my conveyor belt will run. And then if I press technically if I type in / command pause, so it pauses. Alright, now I have a piece of apple here, so we can try and test it out. So I'm gonna put this apple over here. Still moving a bit, but it stopped. Apparently it's taking through this. So here it's returning to the left, which is the class. Alright, so here you can see the image of the fresh apple here. So it identifies this the fresh apple from the project. Right, so then we have a random apple. So now we're gonna test with this item here to indicate random object. Alright, so now it's going to the village indicating. So that's about it. It's detecting the random accuracy of 98%. To be honest, it's kind of weird, but it works. I'm not sure, because we're taking separate images just to send it out, because in Node-RED you can't really save buffer file. And I mean, like, I want to send the image that we have here to Telegram, so I need to take another image to send it in our Telegram sender. Alright, from the previous demo, so over here we have our database visualization. So over here on the top is the percentage percentage of accuracy for each, which is the green is our fresh apple, and then we have the yellow, which is our rotten, and blue is our random class. So down here we have the gauge. We have some gauges which acts as a counter. So in this demo here, I already said that this time, like the interval, like it will count for a day in a duration of 24 hours. So in the last 24 hours we have 20 fresh apple detected, 4 rotten apple, and 17 random items. So I think that's all for my presentation, and I think thank you for watching my presentation for today.